I'm just going to talk you through a bit about the pedagogy of the interventions. And I don't want to get bogged down in the theory. What I want to do is show you the pedagogy in practice. By showing you just some of the intervention materials, which Tom has already run a little bit through, and demonstrating to you the thinking that we've done in preparing these intervention lessons, thinking that we believe will really help your students understand the concepts, and thinking you now don't have to do, so saving you time. But before we look at any of the intervention materials, I just want to talk very, very briefly about the key broad principle that underpins them all. And that is the principle that students have met the concept before. And it might seem obvious because, of course, we know that you've previously taught it, you've assessed it, and you've discovered that the student needs some intervention work on it. But the issue here is that it's likely that the students haven't only met the concept once before and just forgotten what they've learned, but they've possibly met it many times before. Because for reasons beyond this webinar, there's quite a lot of overlap between Key Stage 2 maths and Key Stage 3 maths. So students may not only have learnt a concept from you before, but also from a different teacher before that, and they still haven't got it. So there's absolutely no point in teaching it the same way again. This would be like when someone doesn't understand you and you repeat it the same way, but a little bit louder. And it just doesn't work. The response is likely to be something like that. So what do we do? Well, we need a different approach. We need to exercise caution, though. We don't want to make it so different that it's unfamiliar to students and doesn't fit with what they potentially do understand of a concept and so confuses them. So it's a little bit delicate. We need a different approach, but not too different. And that's what we've tried to do in the SHINE interventions. So let's take a look at an example or two. Let's start by looking at this intervention for rounding and estimating. So as I mentioned before, this is a concept that students will have already met at Key Stage 2 in Year 6. So they've already met it before they even reached you in secondary. And perhaps your student has ended up here doing this intervention because they struggled with answering this question and similar ones on the Access Mathematics test. Okay, so first of all, we start by looking at simpler examples, rounding to the nearest 10 or 100. But that's not exactly doing things differently yet, because I'm guessing that's probably what you would do and what most teachers would do. But let's look more closely at the how this is taught in the intervention lesson. Instead of starting by actually rounding numbers, we start with what a rounded number looks like. So rounding to the nearest 10 means rounding to the nearest number that ends in 0, 0, 1, 0, 2, 0, 3, 0, or 0, 10, 20, 30, and so on. This way, students understand what they are aiming for. And I think this is something that often helps with understanding, and yet we often fail to do as maths teachers. So if you think about, say, a recipe book, for example, we're not just given a recipe, often we're giving a photo of the dish. So we know what we're trying to achieve, and that can really help. And if you look at the notes, the slide notes that Tom mentioned before that accompany this slide, you'll see there's a suggestion that to embed this, you count in tens with students from 0 to 90. And then you explain the digits on the end of a number rounded to the nearest 10, and then that the number can in fact be of any size. And this last part is key as it addresses a common cause of confusion and misconception, that only a two-digit number, a number with tens and ones, can be rounded to the nearest 10. And I'm sure you will have noticed that so often students get stuck when given a three-digit or four-digit number and asked to round to the nearest 10. So here, we offer practice in recognizing numbers rounded to the nearest 10, including not just the 2-digit numbers, but 3 digits, 4 digits, and even 5-digit numbers as well. And the teacher notes down here suggest consolidating what is learnt so far by asking students how they know that 42, 2,758 and 11,567 are not rounded to the nearest 10. And then to consolidate even further, we ask students to write their own numbers rounded to the nearest 10. And this is all before students are even asked to do any rounding. A similar approach is adopted later on in the intervention when beginning to consider rounding to the nearest 100, with students exploring what a number rounded to the nearest 100 looks like, and then being asked to identify numbers rounded to the nearest 100 and write some of their own. Students should then be able to recognise numbers rounded to the nearest 1,000 and even 10,000 and beyond in the same way. So in this intervention, we adopt the different approach of beginning by showing students what they are aiming for. So what do you think happens next? What would you teach them now? So they know how to identify a number rounded to the nearest 10 or 100 or 1,000. I'll just give you a moment to think and even perhaps jot it down. So you may have thought of moving on to rounding 2-digit numbers only, or perhaps rounding down only, down to the nearest 10, or considering the tens that a number lies between. Well, we rejected this first idea because, as mentioned before, we don't want students to become so familiar with only rounding 2-digit numbers to the nearest 10 that they then struggle to understand that other bigger numbers can be rounded to the nearest 10 as well. And we rejected this idea because before rounding down, you need to understand some other concepts first, like the tens a number lies between and which 10 is closest. So this feels like it could be a bit of a jump for intervention work. So this is what we decided to do next, considering the tens a number lies between. And the reason I've included this slide in my presentation is to reveal to you some of the thinking that has gone on when planning these interventions. So you can be really confident when you open one of these intervention lessons of the pedagogy that embeds within it. So let's now look at exactly what happens next in this intervention after students are now familiar with what a number rounded to the nearest 10 looks like. Here, a highly scaffolded approach is taken. Students are told the 10 before 42 is 40, but must decide on the 10 after 40. And then to help students over here, we have a number line, a pictorial support. And then they're asked they can use a number line or not to see which it's closest to, whether 42 is closest to 40 or to 50. And the same type of scaffolding and pictorial support is provided for rounding 2,758 to the nearest 10 as well. And further possible support appears in the slide notes once again, where it's suggested that struggling students may benefit from having all but the tens and ones digits in a number covered over. So here you would cover over the 2 and the 7, so they can only see 58. And students are just left considering that number, and it's much easier for them to determine that 2,758 lies between 2,750 and 2,760. Then finally, on this slide, students work on the tens that 11,567 lie between, and which is the nearest, again with similar support in the hints over here. And you might note that this time, students must identify the previous 10 rather than the next 10 to the number. And we've done this deliberately to stop students going on autopilot and making assumptions about what is required in an answer. Also notice that students are only working on the 10 a number rounds to. The language is really carefully crafted. There is no mention of rounding up or rounding down, at least yet. And so in this intervention, as well as adopting the different approach of showing students what they're aiming for, we've also adopted a highly scaffolded approach with pictorial support. And this is common to an awful lot of the intervention materials. A similar approach is adopted for rounding a number halfway between two tens. So students work out the tens a number rounds to and round to the next 10. And you can see here. And once again, we have the hints with the pictorial support. It is not until students repeat this same learning process for rounding to the nearest 10 and 100 that they're introduced to the language of rounding up and rounding down. And so this slow introduction of language is another deliberate pedagogical strategy that commonly occurs across the interventions. And now here's another example of a slide that Tom showed you to embed understanding even further. Students are encouraged to use the language of the concept for themselves by vocalizing their opinions. So on this slide, students are given an explanation of rounding to the nearest 10 that they may well have met before. That simply tells them to consider the digits of a number. And then once they've discussed it, they can check their answer, whether it's true or false, by clicking answer. A similar explanation appears in opinion 2, but rounding to the nearest 100. And once again, they can check their answer. The hope is that drawing on the learning students experience throughout the intervention, they will now be able to make sense of the explanations they may have met previously relating to this concept. And so while a different approach has been taken, it's not entirely different as to being really confusing for students. Let's just look at another intervention. Let's look at equations. And perhaps your student has ended up here because they have struggled with answering this question or similar ones on the Access Mathematics test. Once again, first of all, we start by looking at simpler examples. So equations with one operation before equations with two operations. And again, that's not exactly doing things differently yet, because that is surely what most teachers would do. But once again, let's look more closely at the how this is taught in this intervention. Instead of starting by working with equations, we start with something familiar, and not just familiar, but something really familiar that students should have learned early in primary maths and had reinforced time and again throughout key stages 1 and 2. That is the idea of the inverse operations of addition and subtraction. And an animation confirms the related addition and subtraction calculations using an example involving 4, 3, and 7. This way, students should be in no way daunted by the concept of algebra or equations. In fact, they should be very comfortable with the starting point. Students then practice the familiar idea, supported by a familiar pictorial representation, the bar model, in a hint. And you can see that they can very clearly see that 28 add 17 equals 45. 17 add 28 also equals 45. 45 subtract 17 gives 28. And 45 subtract 28 gives 17. So they can use the representation to identify the related addition and subtraction calculations. And they practice this with just numbers. Only now are students introduced to the idea of an equation. That is, it's a statement that contains unknown numbers represented by letters, and it also has an equal sign. Again, this is something students should have met at Key Stage 2, albeit they may not be as familiar with it as inverse operations. But that's okay, because we are about to work with the familiar inverse operations to tackle understanding of the less familiar solving equations. So they are shown an equation there and asked for 3 related equations. And you can support them with a bar model just as before. Here you go. So students should be able to see from the bar model what the 3 related equations are. So we've got x plus 18 equals 33, which is our original equation. 18 add x equals 33. 33 subtract x gives 18. 33 subtract 18 gives x. So there should be nothing unfamiliar there. Now students are asked to choose the related equation with numbers only on one side of the equal sign so they can find the value of x. And there it is. And this enables them to then solve the equation. The beauty of this explanation is it relates to the way students are likely to have been taught to solve equations using an inverse operation, getting x on one side of the equal sign, and so on. So it won't be hugely different to how they have learned before, but it is somewhat different in that it draws heavily on what is already familiar to them and doesn't require them to identify the relevant related equation with x on one side in one go, immediately after being presented with the original equation. And so it's highly scaffolded, and then there is the pictorial support with the bar models. And then there's an opportunity for practice with a hint provided, and this time students are encouraged to draw their own bar models, something they should be able to do as they will have likely met them previous to this intervention lesson, as well as working with them on the previous slides. A similar approach is adopted later on in the intervention when working with the inverse operations of multiplication and division. And once again, instead of starting by working with equations, we start with something familiar, and not just familiar, but something really familiar that students should have learned early in primary maths and had reinforced time and again throughout key stages 1 and 2. And that's the idea of the inverse operations of multiplication and division. And an animation confirms the related multiplication and division calculations involving 3, 4, and 12. So once again, we've chosen a very comfortable starting point. Then once again, students practice the familiar idea with the familiar pictorial representation of multiplication grids in hints. So they can see that 7 multiplied by 8 gives 56, 8 multiplied by 7 gives 56, 56 divided by 7 gives 8, 56 divided by 8 gives 7. And they get that practice before they even start to work on the algebra. Only then are students introduced to the idea of an equation involving multiplication and the use of related equations and the inverse operation of division to solve it. And you can support them with a multiplication grid, just as before. So students should be able to see from the multiplication grid what the 3 related equations are. Just as before, students are asked to choose the related equation with numbers only on one side of the equal sign, so they can find a value of x. And there it is. And this enables them to solve the equation. Once again, the beauty of this explanation is that it won't be hugely different to how students have learnt before, but it's somewhat different in that it draws heavily on what is already familiar to them. And it's highly scaffolded. And then there is also pictorial support with the multiplication grids. Then there is an opportunity for practice. And once again, a hint is provided and the pictorial support is suggested rather than given to them. And they should be able to do this because they will have met multiplication grids before coming to this intervention lesson and also on the slides previously. Only then do students begin to work with equations that have two operations. And first of all, they have to identify the order of those operations. So they should be able to identify the multiplication and subtraction in this equation and the order of those operations. And having established that, they are then told that they need to be done in reverse order when solving an equation. And then they can move back to how they've solved equations up to now in the intervention lesson. So they're going to do the subtraction and then the multiplication. So the process is the same, writing all related equations using a pictorial representation to help if required. There you go. And then choosing a related equation with numbers only on one side of the equal sign. And in fact, there's two here. And that leaves the student with 3q equals 27. And so an equation with only one operation, which they've already practiced how to solve. There we go. And once again, students get the opportunity to practice what they've learned. And so in what ways is this different to how you would usually teach equations? There's probably quite a lot of similarity there, but I would assume that there's some differences. Hopefully you will have noticed that in this intervention, we adopt the different approach of starting with something familiar and not just familiar, but really familiar from early in primary. And as before, it's highly scaffolded with pictorial representation. I want to look at just one final intervention lesson that covers order of operations. And perhaps your student has ended up here doing this intervention because they struggled with answering this question, or even ones involving powers as well. This intervention begins by asking students to consider answers to work out where multiplication and addition sit in the order of operations. Firstly, they work out the calculation 2 add 3 multiplied by 4, first by working left to right, doing the addition first, then the multiplication. Then they work out the multiplication first, and then the addition. Students are then asked if they get the same answer, and so whether the order of operations matter. Only once they understand that the order of operations does indeed matter, are they told the order that they should do operations and given two deliberately similar calculations to practice on. And once students are familiar with the order of all 4 operations in this way, then they're given even more practice. But here's where the difference lies in this intervention. Students are encouraged time and again to consider both correct and incorrect answers. So slide notes suggest discussions about incorrect answers. And this is a really powerful strategy when there are mistakes that students commonly make when working with a concept. So when first introduced to powers in order of operation, students also carefully consider answers, using them to determine where powers sit in the order. So for example, they start by being given the calculation and answer in part A, and the slide notes suggest asking, do you think the 2 cubed is worked out first and then the 1 is added? Or is 1 add 2 worked out first and then all cubed? So what is worked out first, the addition or the power? Then for question B, a similar question appears in the slide notes. Do you think the 3 squared is worked out first and then the 4 is added? Or is 3 add 4 worked out and then all squared? And then students have to decide on the order of the operations for themselves. And the same for subtraction and powers. and for multiplication and powers, and for division and powers. And as before, the slide notes give you additional ways to embed the concept, often involving discussing incorrect answers with students. Remember, this is a powerful strategy when there are mistakes that students commonly make. And finally, I want to show you this, just one more example of an opinion slide. And these appear in every intervention. And as Tom said, they're an opportunity for students to use the language of mathematics and vocalize their understanding and to confirm and consolidate what is correct about their understanding, but also have challenged what may not be correct. So once again, in this example relating to order of operations, students have the opportunity to identify which calculations may incorrectly, as well as correctly, have an answer, in this case of 9. So if we look at opinion 1, students who have grasped the concept will do the multiplication first before the subtraction and get an answer of 9. Students who incorrectly work from left to right rather than using the order of operations may decide this calculation has an answer of 17 subtract 2, which is 15, multiplied by 4, which is 60, which is not 9. And they can look at the answer to see how 9 is achieved. In the same way, in opinion 2, they have to decide whether the subtraction goes first or the power. Do they get 9 or not? And if they do get 9, they're actually incorrect in this case. And then in opinion 3, once again, do they get 9 or not? And they would be incorrect if they got 9. So in terms of what is done differently in this intervention, we're using answers to embed understanding and raise awareness of common errors. So I hope by now you've got a good sense of the pedagogical thinking that has gone into the SHINE interventions, and that while we have tried to adopt a slightly different approach to help your students, it's not so different in that it throws them off and they can't bring along some of their existing understandings. I would definitely urge you to use those slide notes because, as you will hopefully have seen, they too form a large part of the teaching with the slides and give you lots of extra ideas for ways to elicit understanding and embed a concept and ensure your students can at last grasp the concept that they probably haven't got since Key Stage 2. So thank you for your time, and I hope you get lots of success with using these interventions.